In 1996, Love Grover published a quantum algorithm for unstructured search, delivering a universal quadratic speedup. The problem: given a function f from 0 through n-1 to 0 or 1, with exactly one x star such that f of x star equals 1, find x star. Classically, you need n over 2 oracle calls on average, O of n, linear. Grover does it in about pi over 4 times square root n. For n equals 2 to the 128, classical needs 2 to the 128 calls, Grover needs only 2 to the 64. Grover's quantum oracle phase flips x star. Concretely, O acting on ket x gives -1 to the f of x times ket x. For x not equal to x star, the phase is unchanged. For x equal to x star, the phase flips. On a uniform superposition over all x, the oracle marks exactly one target state without revealing its index. Watch the amplitudes through 4 stages. We start with a uniform superposition where every state has amplitude 1 over root n. After the oracle, x star's amplitude flips negative. After the diffusion step, all amplitudes are reflected about the mean, x star's amplitude grows visibly. Iterating oracle and diffusion keeps growing it. After about pi over 4 times root n iterations, the probability of measuring x star is essentially 1. The geometric picture makes the y obvious. The state lives in a two-dimensional plane spanned by ket good and ket bad. The initial state sits at a small angle theta toward bad, with sine theta about 1 over root n. Each Grover iteration rotates by an additional 2 theta. The optimal iteration count k is about pi over 4 times root n, just enough to bring the vector close to the good axis. Apply this to brute forcing AES. AES-128's 2 to the 128 key space drops to 2 to the 64 trials under Grover, theoretically breakable by a very large quantum computer. AES-192 falls to 2 to the 96, borderline secure. AES-256 stays at 2 to the 128, very secure. The defense is obvious: double the key to 256 bits. Grover is provably optimal. Bennett, Bernstein, Broussard, and Vazirani proved in 1997 that omega root n is the lower bound. No quantum algorithm searches an unstructured space faster than root n. It applies to hash pre-image search, SAT, and symmetric key spaces. But Grover does not break AES, SHA, or MLKEM, it just halves their effective security. Bottom line, Grover delivers a square root speedup for any unstructured search. It costs you half the strength of symmetric keys, fixed by doubling the key length. Together with Shor, this is the complete quantum threat to modern cryptography.